Hello everyone. This is a quick video where I will show you how you can add aluminium or silica into your framework and what options that you have. So I already opened the chabazite structure. You can do this with any kind of zeolite, and I did the liberty of getting into what I would like to visualize. So I have here again a chabazite gauge. What I did for that is I adjusted my boundaries so it gets very nice. For the rest, I added an aluminium atom. How can you do this? Go to structural parameters. You can add, so the silica or silicium was already there. What you can do is add aluminium. You just give it exactly the same coordinates and you get the same thing. Now, obviously, in the blue, only the aluminium is shown. If we would reverse the order from where silicium is first, you can only see the silicium. So this is not ideally what we want because we might want to be having a silica aluminium ratio. Showcasing what you could do is if you want to showcase the silica aluminium ratio, let's say it's that there's the equal amounts of silica and equal amounts of aluminum, you can change the occupancy to 0.5, for example. But then the icons will not show one out of two blue and white as you would expect, but they go into halves. So this high showcases really distribution of what type of atom is there. So if you would put this, for example, 0.9, sorry, 0.9 and 0.1, I forgot to press enter. And we apply it. You can see it gets 1/10 of it. Now this is not ideal. It depends really on what you're trying to visualize. Sometimes you really want to showcase where the aluminum is at and where the silica is at. So what you can do is another method, which I like to use, is let's put this all on one occupancy. And first we orientate to how we want the figure to look like. We take it as it is. And then we create a rastered image. So we export a rastered image. Once we have done that, we just change again the order. We make the aluminium on top and you get the aluminium picture. So you take again a rastered image and you take the aluminium picture. Then you open up your editing software. In this case, this will be Photoshop for me. I've done liberty to do so. So it's just two pictures on top of each other. As you can see, the nice thing is since we took it in VESTA, they are at the exact same position. I will crop this image. So we include only the parts that we want. So usually it's something like this and like this. But this still didn't really help us a lot. What we want obviously is that some parts are blue, some parts are white or pink. So what I will do is first I will change the transparency of this layer, this top layer, and then you can see both atoms on top of each other. And what you can now do is a quick, easy tool is by manually removing some atoms. So I will now just add some aluminiums to it. So what I will do is I will erase part of the top layer, like so. Let's say that we want some of the aluminium still present, but the other don't. And you can calculate this way. You can calculate how many in general or on average aluminium should still be present or not. So I'll just do a few as such. Let's take a bit more. Of course, you have to also think about if aluminiums can be in close proximity or not. This is something obviously that you have to check and validate. But again, I would rather use this only for visualization purposes, not really to highlight really crystallographical units or effects like such. But okay, let's keep on going. Like so. I think I erased everything well. If you put it back to 100% transparency, it's sometimes easier to spot some mistakes. Let's sample over here. And over here, we also missed a few spots. But now it appears to be that some are based with aluminium and some are based with silica. And this way you get a nice figure. Yeah, that's really all that's to it. You save this figure and then it looks like there's a part of the framework is filled with aluminium tetrahedrons and part of it with silica. So yeah, now moving on, one more trick I want to show you is how you can also use space filling models. For example, if you want to remake a figure as such, all you have to do is create a space filling structure. So here I put an LTA and a chabazite cage next to each other. How do they look so bulky? It's actually quite easy. It's a normal structure, you can see, where the oxygen and the silica are connected to each other. I put it in space filling, and in addition, I put it the radius type to van der Waals. You can also specify a radius yourself, but I used the van der Waals, so it's still correct. Then I took pictures of them, put pictures in the orientations that I wanted, and I loaded them in Photoshop as well. And the only thing then that rests you to do is to create these arrows through the structure. And how I made the arrows is very easy. I actually made it into several pieces where I just go until the layer. I manually erase it, given that you are working at a high pixel ratio. So I would suggest to scale it 3 or 4 times when rendering this image. And then you can remove these pixels. You can see if you would really zoom in that I have manually removed all of these pixels. And this way you get the optical illusion that your arrow goes through the structure. And then I added a gradient from light gray to dark gray, and then you have these figures. So sometimes you also have to think outside of VESTA, use a bit of Photoshop or any other photo editing or editing software, and then you can make these nice pictures as well. Thank you for listening.